Hello. Okay. So in today's session, we are going to see how to write Java code or how to use Fabric Java SDK to update the ledger and to retrieve or to query values from the ledger. Okay. So this is the program that we are going to discuss. This program has all the required code to update some value in the ledger or to add new value in the ledger. Okay, and if you remember, we have discussed this code in previous sessions also. I mean, this is the if you remember the session where we discussed about the read write set. So this is the same class where we added the code to see the read write set that peer or endorsing peer sends back to the client after the endorsement, and that endorsement has a read write set. So we have discussed this class. Now we will see this class in more detail today, that how or what functions we need to call to add new values in the ledger. Okay, so in this program, so up to here, right up to this point, adding the peer in the channel, we have discussed in previous session, like how to create the user and then how to create the enrollment class and what is the significance of that and things like that. So we have discussed up to here, and we in the previous session we also discussed about the chain code id, right, and how to create the chain code id. So in this java file also you can see uh, chain code id is created, and to create the chain code id we have just set the we have created an object of the chain id dot builder, which is a inner class defined in the chain code id, right? And so on the builder object we have set the chain code name and the version which we are dealing with, which or where we want to send the transaction, and then at the end we call this function builder dot build to get the chain code id, right, to get the chain code id. Next, client dot new transaction proposal. So this is the client object, and I hope you remember what is the client object. Client object is a object of HF client class, Hyperledger Fabric client class. So here we have client dot new transaction proposal request. So this method, which is a factory method, returns an object of transaction proposal request. It returns an object of transaction proposal request. Okay, so once we get this object, we have initialized this object with chain code id. Next is the very important parameter that we call function. Okay, so if, let's look at our chain code or smart contract that which is written in the Golang. So this is the program that is written in the Golang, and as I have already explained you, to write a smart contract in the Golang, we have to implement an interface called the chain code. So we are implementing that chain code interface here in this Golang file, and that file has two methods. One is called the init and other is called the invoke. These are the two methods that belong to the chain code interface, and it is mandatory for your smart contract to override these two methods. Now if you see invoke, that you need to override, and that come from the chain code interface. It has I capital, okay, and it takes chain code stub interface argument as an argument. Chain code stub interface. Chain code stub interface, and this is your stub. All right, and so in this function, invoke function. So this is the invoke function which will be executed by the peer on this smart contract for each and every transaction. So if your client send a transaction to the chain code, then your peer or your chain code will execute this invoke method. This is the very important. Okay, first thing, your peer will invoke the chain code method. Your peer will invoke the chain code method. Okay, like in case of the instantiation or initialization, init method is called. Similarly, invoke method will be called when your client send a transaction. Okay, now in the previous version, this invoke method used to take two parameters. Okay, uh, two, or I believe, I do not remember exactly, or two or three parameters. Okay, one was the same chain code stub interface, and then there were two more parameters. One was the name of the function and string argument, string array argument. Now in the Fabric 1.0, chain code stub interface was updated. So now this invoke method and the init method take uh, only one argument, or accept only one argument, which is your chain code stub interface. Okay, but you still need the argument that has been passed by the client in the transaction, and you also need the function, a method which your client want to execute. Okay, so invoke method is called when your transaction is executed by the peer. Okay, in this invoke method you can get the function name, right, and the argument, you by calling this method get function and arguments on the stub object. Okay, so first argument is the function name, and the second argument is string array object. Okay, so if you see here, function, set function, this function is nothing but name of the function that you want to invoke on the inside your chain code. So your peer will invoke the invoke method, and then inside your invoke method you have to write some logic, okay, to find out what method your client want to invoke. So in this function argument, okay, in this function variable, whatever value your client will pass in this, whatever value your client will set in this set function argument, that will be that will come in this function variable in the chain code. Now here we can write if else or the switch statement to invoke a particular method based on that function name. Okay, and so this is the function name that you want to invoke inside the chain code. Okay, and then if you see this parameter, as discussed in case of instantiation, this is the uh, string array argument. String array argument, and because it's a string array argument, you can pass n number of elements in this string array. right? You can have uh, an string array of 100 objects, okay, or 200 objects, or maybe just two string objects in this string array. So if you see here, in my case, I have created a string array object, and in this string array object I have only two string objects. First is first value, and other is the hello world, right? So these string array that you will pass from to your chain code by setting it in the set argument method. These values will be available in the chain code through this args. Okay, this args is nothing but an string array. Okay, nothing but a string array. Now in this string array you will have all the string value that your client has passed to you. So if you see here, here is invoke. So function will have invoke, and if invoke function equal to invoke, then I want to call invoke method with I small. So when I call this invoke method, I pass the stuff here and the string array object. So here you can see that it's an string array object, and I'm considering first element in the string array as the key, and the second element in the string array as a value. So we will discuss this go class in detail in the next session, but for now just understand, in the transaction proposal you need to set the function which you want to invoke and the arguments that you want to pass to your chain code. Okay, now it's up to you and your developer how they use this chain code. Then you have here some properties set set for the transaction proposal request, right? Transaction proposal request. And now here is the important thing. So I created a collection object of type peer, and I have added the peer, okay, peer object inside this collection object, and this is the peer where I will send the proposal request. If you want to send the proposal request to multiple peers, then you can add those peers in this collection object. Okay, and this collection object is C letter used sending the in the send transaction proposal method. So send transaction proposal method is the method which sends your transaction proposal to your peers. Okay, send transaction proposal method is the method which sends your transaction to peers. Okay, which peers? These peers. Okay, which transaction proposal request? The transaction proposal request that we created through the client object. So when you call this method and when the execution of this method ends, first a transaction proposal request will be sent to the peers or to all peers which are the member of this collection peer object. Okay, your peer will execute the chain code, endorse the read write set. Okay, your peer will execute the method. Which method? This method. With which argument? These arguments. Okay, and as we know, your peer will not commit the or update the ledger. It just creates a read write set. This read write set will be passed to the sent back to the client in the form of transaction proposal response. But and one more thing before this transaction proposal object is sent back to the client, right? Your peer will endorse this transaction, right? It has to endorse this transaction. So your peer endorse the transaction and send back the response to the client. So this is the here is your transaction proposal response. This is your transaction proposal response. Okay. Then we call this method new channel dot send transaction. New channel dot send transaction. What this method will do, it will send the endorsed read write set or endorsed uh, transaction proposal response to the orderer, right? And then further order will broadcast to all the peers. So we have discussed this thing, right, in detail. So send transaction method is the method which sends the endorsed proposal response to the orderer. Now, to which orderer this response will be sent? It will be sent to the orderer which you have set in the channel. So if you see in the channel, we have set this orderer, and this is the location of orderer, right? So this is what we have been discussing from last or in all our previous sessions. That first you send the transaction proposal, and then your peers execute that proposal, right? But it does not. It basically simulate the proposal in invocation of method. It does not update the state in the ledger, and then it after endorsement, your peer send the response back to your client, and then your client send it to the orderer. Order do the ordering, and then arrange all the transaction and sends the block to all the peers in the channel. And this is at this point your peers commit the transaction. Okay, so this is how this thing works. Okay, so if I can run this program once for you. Okay, so you can see here uh, ledger is updated successfully. Chain code, hello world. Okay, so I think some error has happened because I think I did not initialized this transaction. I mean, initialize the chain code. So let me run it again. Okay, so let me run this program again. Add ledger. Add to ledger. So if it works properly, then we'll see that our ledger is updated, and this time I do not see any error. So that means value has been added in the ledger. Okay. Now we are going to see or discuss other program that queries the ledger. Okay, so this program is again very similar to all the program that we have seen so far, right? And in fact, up to this statement, we have discussed all the things, all the code in the previous sessions, right? So here we have created the object of Hyperledger Fabric client, then we created the object of orderer, peers, and then initialized the channel, created the channel, and things like that. right? So I'm not going to repeat this part again. So I will go ahead and I will explain you what is new in the query ledger .java program, right? And basically we are going to see in this program that how to send the query proposal request. Okay, query proposal request. So we have a method called the new query proposal request, right? That we need, that which is a factory method inside the HF client class. So if you want to create a query proposal request, then you can call this method client dot new query proposal request. So once you call this method, it will return you query by chain code request object. It will return you an object which is of type query by chain code request. Okay, query by chain code request, right? Now once you get this object from the factory method, you need to initialize it. So again, set the chain code ID. This let your client know that, I mean the peer know that which chain code we need to execute. That is why we always set the chain code ID. Okay. Then we have query method. Okay, function. And again, so here is the one important thing you need to remember. So when this transaction proposal will go to the peer, right, your peer will invoke the same chain code method. Okay, when I'm saying same chain code method, it means it will again invoke the this invoke method, I capital. Okay, it will again invoke the invoke method. Your peer will execute the invoke method again, right? But this time in the stub object, value of function. Okay, when you will call the stub dot get function and parameters, here value of the this function variable will be query. So whatever you will pass in this method, okay, that value, that string will be available in the function variable inside the smart contract, inside the invoke method. Okay, and the parameter that you pass set in this set are arguments, which is a method again, like we had in the add to ledger Java class. So set arguments is the method which takes the string array argument, and you can pass n number of string objects in this string array object. And in the ledger, in the smart contract, these values, okay, these values will be available to you as an string array object, will be available to you as a string array object. Okay, so here string array arguments. So you initialize query by chain code request object. You initialize query by chain code request object. Okay, and then we will be invoking this method called the query by chain code. Okay, query by chain code. Okay, query by chain code method will send a transaction when you invoke this method, right? When you will invoke this method by passing the query by chain code request object, your client or SDK will send a request to or transaction request to your peer. Peer will invoke the invoke method, and it will create the stub object, and it will pass the stub object in the invoke method. And then you whatever logic you have written here, it will be executed, right? Like in my case, I uh, have a conditional if else statement that check value of function, and based on the uh, value in the function parameter, or the based on the value that has been passed through the set function parameter in the transaction proposal request, I have invoked or called the specific function in the same class. So in our case, because value of function will be query, so this method will be called the t dot query stub, and this is the that method. Okay, so here first argument string argument is considered as a key, and then using that key we have uh, fetched the value of that key from the ledger by using this method. Okay, so anyways, we'll discuss this thing in the next session. So here we have transaction proposal request that we are sending to the peer using the query by chain code method. Okay, by invoking the query by chain code method in the on the channel object. Okay, so this method returns as transaction proposal response. Transaction proposal response. Now here is a very important thing. Okay, in case if you are adding something or you are updating something on the ledger, you have to send another request, or you have to send the response of this transaction proposal. Okay, you have to send the response of this transaction proposal to the orderer, so that order broadcast to all the peers in the channel, and your state, your ledger actually get updated. But in case if you send a query proposal to the peer, you actually don't need to send the your endorsed proposal response to the orderer, right? Because you don't need, you don't want to create a new transaction in the channel. Okay, or you are not updating or adding anything in the ledger. So in case of the query, you if you want, you can skip sending the endorsed proposal request to orderer. So here we get the transaction proposal response, right? And then because it's an a collection, okay, of a proposal response, we have uh, I have used a for loop to read each and every response object which is in this collection, uh, transaction propose PROPRESP. So and then inside the for loop I have uh, a condition that basically validate if the proposal that we receive from the peer is verified or not, and what is the status. If the status of the response is success or 200, okay, we consider that response as a valid response. If it's not 200 or something else, then we consider it as a uh, failed response. Okay, and either you check status response status code, or you can check the response status if the status should be success. So if it's not success, then your response is a failed response. Sorry. Now if you have a valid response, right, if you have if you receive a valid response from the from your peer as a result of execution of your query method, then you will be interested to finding out what value your query transaction has written. To find out that value, we on the response object, okay, proposal response object, we need to call get proposal response. Okay, so get proposal response returns you a proposal response proposal response object, and then on that method you need to call the get response. It returns you the response object, and on that response object actually you can call the get payload method. Okay, this payload method return um, return value, actual value that was stored in the ledger, okay, or the result of the uh, execution of your query method. Okay, and then in my case I have converted into a string UTF-8 string. Okay, it was written as a string, but I have converted explicitly to string UTF-8. Okay, so this is the payload that is written by the smart contract after execution of your query method. Okay, so the point that you need to remember, if you send a query transaction to the peers, you don't need to send the endorsed response to the orderer, uh, so that it gets broadcasted to all other peers. Okay, but in case if you are adding or updating a ledger, it is mandatory for you to send the endorsed response to the orderer. Okay, so that's it for today. In the next session, we'll discuss some other things about the Java SDK only, and we'll see what is the next topic in the next session. Okay, so that's it for today.